Tabletops are effective tools for interaction with two-dimensional spatial data. However, three-dimensional data are significantly less easy to manipulate with a flat surface. Complex or precise transformations are not possible without resorting to less natural styles of interaction, such as a special language of gestures. Active tangible widgets, like CubeTile, or this prototype touch cube we have here, work well, but they require a source of power and a digital link to transmit data to the tabletop. Moreover, active touch devices don't take advantage of the tabletop itself. So, we designed the TZee as a way to literally extend diffuse illumination tabletops into the third dimension. Our first prototype was built from a solid block of silicone plastic, but light rebounded within the device, rather than passing through it. Our final design consists of a stack of solid acrylic glass in the shape of a pyramid. The steps are covered with thin plastic ramps to provide 5 touch surfaces, and reflective markers are placed on the bottom so the tabletop software can recognize the device. TZee was inspired by passive tangibles such as lumino blocks, which are powered from the same light source and touch recognition engine as the tabletop itself. However, TZee is unique as it has 5 touchable sides, enabling 3D manipulation in much the same way as CubeTile. As we see from these demonstrations, placing acrylic blocks upon the tabletop surface enables the camera to detect finger touches that would otherwise go undetected at the same level in the air. We were able to sense touches through 3 of these blocks with our ordinary DI tabletop. By adding these ramps, the user is able to slide their fingers across the stepped edges while most of the light transmission is preserved. Notice that the shell doesn't work well on its own, especially near the top. As light passes through the table's surface diffuser, its intensity at each point follows a Lambertian profile, as shown here. However, when the air above the table is replaced with an acrylic block, this profile appears to narrow, thereby increasing the intensity of the light transmitted. This is due to refraction at the diffuser-air-acrylic interface. TZee enables essential transformations like rotation, scaling, and transformation in all 3 dimensions with 1 or 2 hands. Rotation around the X or Y axes is accomplished with an up or down swipe on one of the angled sides. To rotate around the Z axis, simply spin the device itself. Translation along the XY plane is accomplished by sliding a finger along the top face of the widget. Movement in the Z direction is performed with a pinch and drag gesture. To move an object towards the screen, pinch 2 sides and lift. The inverse gesture pushes objects away. Here, we demonstrate the 2-handed scaling gesture. TZee accommodates stretching or compression gestures in all 3 directions. This is how objects are stretched and compressed in the Z direction. TZee also supports more advanced gestures, like slicing a volumetric object, for example. By placing one finger and making a cut with 2 others, the interior of the object is exposed. Here, we see a gesture that deforms an object by moving one corner independently of the others. TZee is expressive, yet affordable, and it also offers special advantages. Because of its unique construction, light passes straight through the widget, allowing feedback or other helpful hints to be projected upon it. Here, we show a menu that allows TZee to be bound to a particular object in the scene. In conclusion, TZee is a step forward in interactive surface design, a passive tangible widget that literally adds a new dimension to tabletop interaction.